this is the setting. So we'll just have a battery, which is simply some energy levels. So this is the lowest one, and then they go up. And then in this battery, we'll have a state. So it's a quantum battery, so when one can think of an electron or a photon or any quantum system, then this state can be in any of these energy levels. So usually, we will describe it as a probability distribution. So this would be a representation of a state. So if here I have these two guys, I just mean that this probability is higher than this other one. Okay? Well, then how do we extract work? So, for example, we see here this battery. It has quite a high energy, and work can be extracted by reordering these probabilities. So, for example, here, this is the optimal reordering that gives me the maximal work. So, to extract work, I take these probabilities and I reorder them in such a way that the energy of the battery decreases. Okay? Then there is an interesting notion, which is that of a passive state. So this is a state which do have energy, but no work can be extracted from it. So as you can see here, any reordering of these probabilities won't help me. So the energy will only increase. So if I do any change here, I will just get more energy, and that means that I'm giving energy to the system. So the system is never giving energy to me. So I cannot do anything useful out of it. Well then, usually in quantum physics, stuff gets interesting when we have more than one system. Okay, so consider now we have two passive batteries. So as you can see here, no reordering will give me more, will give less energy, so will give work to me. Okay, so from here I can do nothing. But now, out of these two batteries, I think of a global one. So I just treat the system as a global system. So that's very easy. So this global battery, to construct it, the lowest energy will be just the sum of these two low energies. So 2 times E sub 0. Then the probability will just be the product. And then I go so on and so forth, and I have this global battery. Well, I mean, I did nothing. I just treat the system in another way. But why is this interesting? Because we see here that there is one exchange that will give me energy. So the point is that whereas individually there's nothing I can do, these batteries are useless. If I act globally, then work can be extracted. Okay? And this, I call it activation. And then, so my research now, well, we are trying to connect a bit this activation with entanglement. And this is a very natural question because, well, entanglement, in a way, it can be described as if I have a joint system, I cannot describe such a system as the sum of pairs. So so here I give a very famous example where I can have two particles and they can either point up or down. So say one possible state is both pointing up, another possible state is both pointing down. But now in quantum physics, we also can have superpositions of these states. So I can have a superposition which is a sum of being up, up, and at the same time, down, down. So then, as you can see here, there's no way I can express this as a combination of two subsystems. It's just a joint correlated system. So again, going back to the batteries, we started with two separated batteries. At the end, we have two separated batteries as well with another energy. But okay, what happens in between? Do they get entangled? Do we need entanglement for this process? How much? So these kind of questions, that's what we are looking for. Thank you.